Hello. So now we're going to do a little bit of discussion on exponentiation, okay? The basic definition, as I alluded to earlier, is that if we let x be a non-zero number and we let n be some whole number, then x to the n means x times x times x dot 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 times x, where I have n copies of x being multiplied. The number x is called the base, and the number n, the number x is called the base, the number n is called the exponent, okay? And, or power. So for example, okay. So for example, let's say we have 2 squared. The 2 is our base, and the exponent, the 2 here is the exponent, okay? And this is equal to 2 times 2. Now the reason why I'm starting with this example is that a lot of students make a mistake. They think, oh, this 2 is being multiplied by that 2, and that's why it's 2 times 2. But that's exactly wrong. The real way you're interpreting this as 2 times 2 is that the base x, which is 2 in this example, is being multiplied with itself, the number of times as indicated by the power, which is 2. So there are 2 copies of the base x being multiplied. So in other words, there are 2 copies of the base x of the base 2 being multiplied, okay? Okay, and of course 2 times 2 is 4. I wanted to give that example first to clear up some of the confusion people have. Now if I have something like 3 squared, this is 3 times 3. Why? Because my base x is 3 and my exponent is 2. So therefore I know that I'm going to have 2 copies of 3 being multiplied together, and that's going to give me 9. Because 3 times 3 is 9. Okay? Now, let's make this a little more interesting here. Let's talk about, let's say, negative 2 squared. Negative 2 squared, by definition, by this definition, is negative 2 times negative 2. Okay? Because the base here is x. The base here, x, is negative 2. And so I'm going to have 2 copies, because my exponent is 2, I'm going to have 2 copies of that base being multiplied together. So therefore, negative 2 times negative 2. Now, a negative times a negative is a positive, and so we know that the result will be positive, and 2 times 2 is 4, so we're going to have that this is equal to 4. Okay? Now, let's look at what happens if I have, let's say, negative 2 to the cube power. Well, I'm going to have 3 copies of the base negative 2 being multiplied together. So that's going to be negative 2 times negative 2 times negative 2, okay? Negative 2 times negative 2 times negative 2 being multiplied. And that's going to give me, I know this will multiply to give me positive 4, because that's what happened here. But then positive 4 times negative 2 becomes negative 8. And so we can see that negative 2 to the third power is negative 2 times negative 2 times negative 2, which is negative 8. Okay? Okay? And so one of the things I want you to, and so let me also say that. So, yes. Now let me do a couple more examples here so that we can see this being used a little more. But before I do more examples, let me just stop a moment and let me make a comment here. The reason why exponentiation is important in algebra is because up until now, when you were doing arithmetic problems where an exponent might come up, like for example when you multiplied numbers, you could simply have multiplied those numbers and be done with it. The chance of there being a situation where you would wanna capture the product of multiple numbers that might be the same wouldn't have necessarily happened. Like for example, if I was looking at this square and it's like 2 times 2, I wouldn't have thought of writing the area as 2 squared. If I'm looking at it from an arithmetic perspective, right, the area of a rectangle, of which a square is a particular case, would just be the length times the width, right? And in this case, since it's a square, I would just write 2 times 2. But instead of seeing that as 2 squared, I would have just seen that as 4, because I could just simplify it. So the chance that you would have to codify a calculation like 2 times 2 times 2 times 2, whatever, would not be seen, because if you were to look at this expression, you would just have started multiplying, and you'd be done with it. You would see that this is 16. But in algebra, when we introduce variables, we're going to have a notation to take care of this, and that's where exponentiation comes from. And so, for example, if you look at this, you'll see, this expression, 2 times 2 times 2 times 2, there are 4 copies of 2. So therefore, since the n refers to the number of copies, and since what's being multiplied refers to the base x, we can see that we can write this as 2 to the 4th power, okay? And also, if you do the calculation, you will see that this is equal to 16, okay? Okay. And so now let's continue a little bit here. Let's continue with like a couple more examples and where this is going to really play a role for us, okay? Okay. So let's say I have x times x, for whatever reason. Then I know that this is x squared. Why? Because there are 2 copies of x being multiplied together. So since the n refers to the number of copies of the base being multiplied, since the base here is x, and since the number of copies is 2, that's x squared. What if I were to write x to the 3rd power? That would be, by definition, x times x times x, because I have 3 copies of the base x being multiplied together. The exponent is the number of copies being multiplied, and the base x is what is being multiplied. Okay? Now, let me show you an example that's more interesting. What if I have 2x raised to the 3rd power? What is this? This is more interesting. Because by definition, this means that the base, 2x, is going to be multiplied with itself 3 times. Like this. Okay? And now, I'm not going to go into the full detail right now, but basically, we know that multiplication is commutative, that you can interchange the order, and also that multiplication is associative. That is to say, if you were to have 3 numbers, like let's say a, b, and c, and you multiply the a, b first, and then multiply by c, that'll give you the same result as a times bc. Then, using those rules, you will eventually arrive at the conclusion that this will become 2 times 2 times 2, which is 8. X times x times x. What is x times x times x? From here, we know that that's x cubed. And so we can see that 2x cubed is equal to 8x cubed, okay? Now we're going to look at some more examples like this in a few moments, but I want to stop here just so we can take a breath and so that we can look at some of the properties that this notation will possess, and some motivation for why that's the case. Thank you.